All right, ladies and gentlemen, let's talk about angle relationships. This will be the second time we're discussing them. In this one, the new part are called vertical angles. We've already talked about adjacent angles. Those are angles that share a vertex in exactly one side. So like angle 2 and 3 right here, they have this vertex and they have this common side right here. Those are called adjacent. Complementary angles, you can see that if you change the C into a 9, it looks like a 90 right there, and that's what complementary angles are. And for supplementary, you can take that S and you see how you can make it look like an 8? That's a way to help you remember that supplementary add up to 180. So let's talk about vertical angles. First thing first, that means that if they're vertical, they're going to be congruent, which means that their measurements are equal to each other. They are the same exact side. Now, what makes two angles vertical is the fact that they're going to share a vertex, like this right here, and they're made by common lines. So they're going to be on opposite sides of each other. So like, for example, you see this one right here? I got angle 5 and angle 3. I got them marked out. Do you see this line is one side of angle 3. It's also a side of angle 5. And this line right here, same deal. This line right here, you see this is the other side of angle 5. It's also the other side of angle 3. So we're going to say that that angle 3 is going to be congruent to angle 5. Their measurements are the same. So for example, let's say this was 42 degrees. This would also be 42 degrees. Now, where things get tricky is people say, they often mistake, and they say, well, look, it may be that 2 and 4 are also vertical, but they're not. Here's why. Angle 2 is made by this line right here, and so is angle 4. They share that in common, no problem. They're not adjacent to each other because this isn't this right here is not a common side of both angles. It's just for 2. But 4 is also made by this one, and 2 is made by this ray right here. So 2 and 4, they're not vertical. They kind of look like it, but they're not. So you got to be careful with that. All right, let's see a couple examples real quick where you're going to use these relationships to, well, discover some things. So let's see, make that a little brighter. All right, let's start with this one right here. Turns out these two angles right here, this one and this one, they're vertical. The reason I know that they're vertical is because they share this vertex, and you see this is a segment that makes this angle, and it helps to make this angle, and this segment also makes the same exact angle. So I know that 56 is going to be equal to 3x plus 2 because they're vertical. And since they're vertical, I can go ahead and set them equal, and I can solve it. I'm going to subtract 54 equals 3x, divide by 3, 18. See how that works? Pretty cool, right? Now, let's talk about this one right here. These two angles, they're adjacent. And all three of them add up to 360 degrees. So I can say this plus this plus this equals 360. So x minus 53 plus, I've got negative 40 plus x plus 2x plus 1 equals 360 degrees. See, this angle plus this angle plus this angle. So x minus 53, negative 40 plus x, and 2x plus 1 equal 360. Now, because all of these are on the same side, I can just rearrange the order. They're all adding. So, you know how you could do 3 plus 5 is the same as 5 plus 3. You can rearrange it. So I have 1x plus 1x plus 2x. That's 4x. See? 1, 2, 3, 4. 4x. And then negative 53, negative 40, and positive 1. So 53 and 40, they're both negative, right? That makes negative 93 plus 1 is 92 equals 360. So now you're just going to take that 92 and you're going to add it to move it to the other side, and you're going to get 4x equals 452. Divide by 4, and you're going to get that x is equal to 113. Now, if it just said that, you'd be done. If it said solve for x, you'd be finished. So if it said solve for x, you'd be done. However, if it said find the value of each angle, well, you'd have to plug this in. So this one would be negative 40 plus 113. This would be 113 minus 53, and this would be 2 times 113 plus 1. So you just have to do the order of operations right there. So what is that? 226 plus 1 is 227. That would be that angle right there. And let's see, 113 minus 40, that's going to be 73. And 113 minus 53 is, of course, 60. So that's how that works. All right, let's see one last one. This is maybe the one that would cause the most kind of trouble, this style right here, because people are going to look at the 60 and the b and they're going to think that they're vertical, but they're not. The reason they're not vertical, well, they are both made by this line right here, and they do have a common vertex, but they don't share the other side. You see, this is the other side of B, and this line, if I continue it, it doesn't make the other side of this angle that's marked 60. However, this is a line right here. This side's 90. So that means these two right here, these have to be 90 also, which makes that 30. And this angle and this angle right here, they're vertical, so they're going to be equal. There you go, equals 30. Hope this has been helpful. Just be really careful with those vertical angles, and you should be all right.